So writing explicit equations for arithmetic sequences. It doesn't mean we're going to have a bunch of swear words in there. It just means we're going to have an equation that is explicitly written out so that we can, from that equation, find any term we want. We don't have to find the entire sequence up to that term. So we use subscript notation. Subscript notation is what kind of notation? The letter or number underneath the regular writing line. It's a small number. So this is subscript notation right here. We kind of talked about subscript and superscript earlier in the year. The notation is A, you would say like A sub 1, A sub 2, or you could just say A1, A2, A3, A4, all the way up to A sub n or AN. Okay? A little different look than the A of n with parentheses. The subscript notation is what we use when we're dealing with explicit equations. So the sequence 3, 5, 7, 9, 11, is that an arithmetic sequence? Yes, it is. Because we are changing by 2 each time, 3, 5, 7, 9, 11, 13, 15, 17, 19, and so on. A sub 1 is the first term right there. A sub 2 is the second term right there. A sub 3 is the third term. A sub 4 is the fourth term, and so on. Okay? A sub n would be the nth term out here somewhere. Whatever that term number is. If you want the 10th term, then A sub 10 would be somewhere out here. And that's what this is saying right here. The nth term is the sequence, in the sequence is A sub n. So the equation to find the nth term, whatever that term number is that you want, if I want the 142nd term, the equation to find that would be A sub n equals A1. What's A1? In this sequence, sure, it's 3, but what is A1? It's the first term. So I'm going to write first term. This n right here is the same as that n right there. So if I want A sub 15, then I'm going to put a 15 right here also. And what's that D? We talked about the D yesterday. Two words. Starts with a C. Yeah, common difference. So if a sequence is an arithmetic sequence, you can use this equation right here to find any term you want. Okay? By the way, it happens to say D is the common difference sitting right there. We can use the information given to substitute for A1 and D, and then simplify the equation using the distributive property if it asks us to do so. Okay? Then from there, we'll be able to come up with any term we want. We want to write an explicit equation first, and then we want to find the 10th term in the sequence. Well, we could probably sit here and figure out what the 10th term would be anyway, right? So let's do that. Let's do that first. What is the 10th term? So if I'm looking at this sequence right here, how am I changing each time? I'm adding 4 each time. So I'm at 0 right now. The next term would be 4, and then, okay, how many terms is that? 8, so I need 2 more to get the 10th number in the sequence. So 20, 24, okay? My 10th term is 24. So that is one way that you could find the 10th number in the sequence. And so some of you probably are thinking, well, why don't I just do that rather than having to come up with an equation and do all this extra work? The reason you want to do that equation is because what if instead of the 10th number in the sequence, I said give me the 310th number in the sequence? You're going to be sitting there forever. And it's going to take you like 2 or 3 pieces of paper and maybe an hour and a half. Probably the entire voice, even if you recorded it, would be over with by the time you got done figuring out what the 310th term was. And what if you made a mistake somewhere along the way? Terrible, right? So come up with the equation. It's way more powerful. The algebra that you're going to do here is actually incredibly powerful. The equation that we're using is A sub n equals A1 plus, the way that I wrote it on the last page was n minus 1 times d. You could also write the d here and then do the n minus 1 here. The distributive property is the same either way. Now I'll just substitute in what you know. A sub n sticks around. What's a sub 1? It's negative 12. The first term in the sequence is right there. So I'm going to write negative 12 and then plus, what's my common difference? 4. We changed by 4 each time. From here to here was 4. From here to here was 4. From here to here was 4. That's the D. So I'm going to write 4 here and then parentheses n minus 1. That's the equation right there. If it wants you to simplify it down, then we can. We distribute the 4 in. A sub n equals negative 12 plus what? 4n minus 4. Okay, and then after you distribute, you always have to combine like terms. So a sub n equals, that 4n I could write here. And then the negative 12 minus 4 is negative 16. So there's your equation right there. Now it asks you to find the 10th term. Well, that means I'm looking for a sub 10 equals. That n right there turned into a 10, which means that n right there is going to turn into what? A 10. So I'm going to write 4 times 10 minus 16. So a sub 10 equals 40 minus 16. So a sub 10 equals, what's 40 minus 16? 24. And that's your answer. And that's the same answer we got above by finding the 10th term just by writing out the entire sequence. So if I asked you for the 310th term, and you started writing way back when I said, what's the 310th term, you'd still be on like maybe 50 or 60, somewhere in there. Let's go ahead and find the 310th term here. That would be a sub 310 equals 4 times 310 minus 16. We'll get your calculator out and do 4 times 310. $12.40 minus 16. So a 310 equals 12.24. Now I can watch The Voice without having to do my homework. Pretty nice. So I want to write an explicit equation for this sequence right here. First of all, is this an arithmetic sequence? How do you know? How much do we change from here to here? 7. Negative 13. From here to here? Negative 13. Here to here? Negative 13. So it is an arithmetic sequence. And by the way, by doing that, I know something already from this right here. What is that? That's the common difference. So I already know everything I need to know to write that equation. I'm going to write a sub n equals what? A sub 1, which is 3. So then the common difference, which is negative 13. So I can write minus 13 times the n minus 1. And that's the equation. Technically in the equation over here it says plus, but the d was negative 13. So I'd write 3 plus negative 13, and plus negative is the same as minus. Now we want the 10th term in the sequence, so we are going to write what? A sub 10 equals 3 minus 13 times 10 minus 1. All right, now in the parentheses first, simplify that. So we have a sub 10 equals 3 minus 13 times 9. So a sub 10 equals 3 minus 13 times 9. 10 times 9 is 90. 11 times 9 is 99. 12 times 9 is 108. So 13 times 9 is 117. So 3 minus 117, a sub 10 equals positive or negative? Negative. 3 minus 117, 114. There's your answer. All right, now that we know recursive and explicit formulas, we can go from one to the other or from one to the other way. So if you're given a recursive formula, if you're given the recursive formula, to switch to an explicit formula, just take the common difference from the recursive formula. And they're going to tell you the first term. They will tell you the first term. So now you have the common difference, which is sitting right in front of you, and they're giving you the first term, which means you can go straight from the recursive formula, which is sitting here, to the explicit formula. The explicit formula is a sub n, not a of n, a sub n equals what? A1, which is 19 plus the common difference, which is, that's the common difference right there, D. So plus 12 times, that's the answer. By the way, this should be a capital A right here. That's a typo. Doesn't really matter, but might as well be correct. Okay. Plug both into the explicit formula and you're done. That's what we did. That's the answer. It takes like one step. Write an explicit formula from the given recursive formula. Here you go. Here's the given recursive formula. They told you the first term. What's my explicit formula going to be? That's it. If you liked that, you're going to think this is even better. If you're given the explicit formula and you need to write a recursive formula from it, the only thing you need is the common difference from the explicit formula. Once you have the common difference, just plug it into the standard recursive formula that we've been seeing, and you're done. It's like one thing that you have to do. So write a recursive formula from the explicit formula. What's the common difference in this one? It's 10. So then the recursive formula is going to be A of n equals A of n minus 1 plus 10. That's it. So what's the last one? The common difference is 3. So I'm going to write for a recursive formula plus 3. And all that recursive formula says is I take the term before it. To get the next term, I add 3 to it. That's all that says. The term I'm looking at is the term before it plus 3.